Hello and hartelijk welcome from BASTA Spring 2017. I'm Mascha Schnellbacher and I'm here with Pieter Buteneers. He's a data strategy and machine learning consultant. And so, welcome Pieter, nice to have you here.
Thank you.
You actually just held a keynote about machine learning. And I wanted to ask for starters, what defines machine learning?
Well, actually, the whole field of machine learning is based on learning from examples. So it means that you can have a computer program that can learn how kids or yourself, how you learn. So you see a lot of examples, and based from those examples, you learn what to do. And machine learning basically does the same thing, but then in a computer algorithm.
All right. And could you explain yourself why it is such a hype today?
Actually, it is causing for a lot of breakthroughs. So the problem with hand-coded algorithms is that you can only look at a certain amount of data yourself. So it's kind of difficult to build an algorithm that thinks about everything. And if you compare to how we humans do it, we just see a couple of examples and we can generalize quite well, and we can do those tasks really easily. So in the olden days, computers weren't strong enough to learn the whole system. So quite recently, computers have become fast enough, especially with GPU computing. So currently it's technically possible to train those algorithms on computers, but also the fact that they can learn from examples makes it so much easier, because the engineering time required to build a system with your own knowledge, which is a limited view on the world, is so limited in a sense that you can't build such algorithms. And with machine learning, you can go much farther, and you can just show them the examples, and the algorithm will learn what the relationship is between what it's shown and what it should give as an output.
How can machine learning and artificial intelligence help us as developer, you said it, and as normal human being in our everyday tasks? Machine learning, basically, I said it very short in my talk, can be used to automate like daily things that you do. Things that are very repetitive, actually quite boring to do. And if there is something that you do very often, you can be very sure that you can solve that with machine learning. Because of the fact that you do it very often, there are many examples of it. So as a developer, if there is something in your work or whatever you do that is very repetitive, you can build it with machine learning. Similarly, for tasks that your company does, so a simple example are chatbots. So you have a lot of customers asking more or less the same question. But the fact that the question is more or less the same means that the answers are usually exactly the same. So if you can build a system that can learn which questions are related to which answers, you can automatically answer all those questions, and you don't need people to go to the frequently asked question part on your website. They can just ask in a natural way what they want to know. And that's a simple example of what you can do. Well, simple in the sense that it's easy to understand what's going on. Okay.
But on average, actually everything that is repetitive can be replaced by machines or computer algorithms like machine learning algorithms.
All right. So speaking about bots, what is your opinion about personal assistants like Cortana and Alexa? Are they useful yet?
For me, I don't use them. I like to play with them. They're nice to show in presentations, but personally, I haven't found like a real use for it. Sometimes I'm too lazy to type on my keyboard, and then I will say, "Okay, Google," and ask, for example, what's the weather tomorrow. But usually, it's very basic questions that I know that they can perfectly answer. On most occasions, if I ask like a more tricky question, the answer is not always what I want. But I noticed that like in recent evolution is that you have Siri from Apple, you have Cortana from Microsoft, but I noticed that OK Google, the Google Assistant, is getting a lot more powerful recently. So they we're lagging behind for a while, but it seems like that one is getting more intelligent, but still not intelligent enough for my use. Alexa I haven't used yet, so I don't know how well it functions.
Yeah, and what are your own experience with machine learning? What do you say works just yet and what doesn't?
Well, actually everything that you can keep simple in a way works. So if you have a lot of examples, and you can make it really complicated, but if you have models that are somehow simple, they work in any case. But I think it's too limiting to put it like that. Basically, if you have enough examples, you can do anything. And it's just a matter of fact of using those examples as training data. And if you understand that data, if you know what the relevancy is of certain features, we call them features, so aspects of that data for your algorithm, you can extract those features from your data and make the process easier. So basically, if you understand your data and you know as a human what's going on, and you know that you can solve the task, and you have to solve that task quite repetitively, you can do all those tasks with machine learning.
Okay. And do you have an example of how you tried yourself to implement machine learning in a process or system? You can talk.
Yeah, well, I've had my talk on anomaly detection, of course, but I'm going to give another example. It's from one of my customers. They do monitoring of solar panels. And basically they want to know if something in their system goes wrong. So they have the panels, and then they have the inverters that convert direct current to the current to go on the net. And all those systems have certain losses. So basically from how much sun will shine, and they can measure that with a certain module, you could determine what the output should be. But it's really hard to build a system that takes all the parameters of the solar panel. Like some solar panels are more sensitive to the sun being in a different angle. The brightness of the sun has a lot of influence on how the panel produces current. So instead of making an algorithm and fine-tuning those parameters yourself, with a customer, we build a model that can learn from the solar input what the output should be. So that's another example. So you can basically learn from examples what it should be, and they use that system to determine when one of the panels is malfunctioning or one of the inverters is malfunctioning based on the sun and the time of the day.
All right. And so you said it, machine learning is basically learning like humans, kind of.
Yep.
So do we have to be afraid that machines become smarter than us? Like, think about Skynet.
Well, actually, to be honest, the probability is quite high that that will happen. We're more or less at the level of, well, insects is maybe not perfect, but we can do a lot of things that insects can do with machine learning. Even though insects are more complex than we dare to admit, they're more intelligent than we think. But there's a lot of stuff that we can do already. But since we have reached that level, moving up to human level is not that far off. So actually we should be afraid that many of the jobs that we have now will be replaced with machine learning. But on the other hand, I don't think we should be that afraid, because what will be replaced, especially in the beginning, will be the jobs that are very repetitive. And we humans are, in a sense, very creative, even though our education is focused on blocking learning and making sure that you just sit in line, listen to what the teacher says. But in fact, if you look at kids, they are so creative and they can invent so much new stuff. I think if education focuses on making those students be creative throughout their whole studies, I think for the market it won't be such a big issue, because the time it will take for machine learning algorithms to be so creative as we are, that's going to be a long time. But in many tasks they will be more intelligent than we are. And to come back to the Skynet thing, that assumes that your algorithm has emotions, wants to rule the world. What more likely will happen, because if you want emotions, you have to implement them, you have to make the system learn emotions. So the probability that that will happen is quite small, but there's another big issue in machine learning, that you can train your algorithm to become self-learning, which means that it will go online, for example, to learn new things. And if you, for example, program your algorithm to build coffee cups, for example, and you say, you can learn on the internet to do it better, but your goal is to produce as many coffee cups as you can for as little money as you have. And if that algorithm becomes really smart, it might move on to the stock market and start trading to have more money to build more coffee cups. Or it might just consume all humans in the world and turn them into coffee cups, because the algorithm is just asked to build coffee cups. And that's a bigger danger in machine learning. And it will happen at some point that somebody will make a mistake and just let go of an algorithm that does something like that. And I hope we will be in time to pull the plug. So that's why Elon Musk, the founder of Tesla, started an organization to basically direct AI research in the good direction and make people aware of this risk of AI.
Yeah. Okay, then thank you very much for that interesting experience and insights in the field of machine learning, and have fun at the BASTA. Thank you.
Yeah, thank you. Goodbye.